Welcome to qnawire.
So here we need to separate it into three different sections of the problem, essentially. We have the acceleration part, the constant speed. The second part would be the constant speed, and then the third part would be the deceleration. So we can find the maximum speed of the train. This is going to be 95 kilometers per hour. Let's just convert real quick. Multiplied by 1 meter per second for every 3.6 kilometers per hour. This is going to be equal to 26.39 meters per second. At this point, we're going to evaluate the acceleration phase. So we can say that v final. So let's say part one. V final equals V initial plus AT. We know that the initial velocity is going to be equal to 0. So T is going to be equal to 26.39, our final velocity, and our maximum velocity of the train, divided by our acceleration of the train, so 1.1 meters per second squared. This is giving us 23.99 seconds. So let's not round until the very end. Let's find the displacement during this part. So we can say that delta x would be equal to Vx initial t plus 1/2 AT squared. We know that Vx initial is 0, so we can eliminate that term, and this is going to be equal to 1/2 times 1.1 meters per second squared multiplied by 23.99 seconds quantity squared. This is going to equal 316.5 meters. Now we need to find the we need to evaluate now the deceleration phase. So here we can say that for the deceleration phase, we'll say acceleration for part one. And then for part three, essentially, because this comes after the constant speed phase, we can say deceleration. Let's find how long it takes to decelerate. So we can say that V final equals V initial plus AT. We know that here now V final is 0 because we're coming to a stop, and T would be equal to negative 26.39 meters per second divided by our maximum deceleration. So this is not the acceleration. This would be negative 2.0 meters per second squared. This is equaling approximately 13.20 seconds. And then let's find the distance traveled during this phase. So delta x would be equal to Vx initial t plus 1/2 AT squared. This would be equal to 26.39 meters per second multiplied by 13.20 seconds plus 1/2 times negative 2.0 meters per second squared multiplied by 13.20 seconds quantity squared. And we find that here delta x is going to equal 174.1 meters. Now let's get a new workbook. We want to find the total elapsed time. So t of acceleration plus t of deceleration would be simply equal to 23.99 seconds plus 13.20 seconds, and this is equaling 37.19 seconds. And then for the total distance, this would simply be equal to 316.5 plus 174.1. This is equaling 491 meters. Now, for part A, we want to find, we know that the stations are spaced 1,800 meters apart, or 1.8 kilometers. So we know that there's a total of 9,000. We can say we can say stations are 1,800 meters apart. So we can say 9,000 meters divided by 1,800 meters. This would equal 5 interstation segments, we'll call it. And at this point, we know that a train making the entire trip would have 5 of these segments. And we know that we have 4 stops of 22 seconds each at the stations. So we can say 4 stops of 22 seconds each. 491 meters, again, is traveled during acceleration and deceleration. So we can say 1,800 meters minus 491 meters. This would equal 1,309 meters at an average speed, or we can say average velocity. So at an average velocity equal to 26.39 meters per second, the maximum velocity of the train. So we can solve for the time, and we can say that time would then be equal to 1,309 meters divided by 26.39 meters per second. This is giving us 49.60 seconds. So the total interstation segment, so we can say T total, would be equal to 37.19 seconds plus 49.6. This is giving us 86.79 seconds. At this point, we can say that we have 5 of these segments and then 4 stops of 22 seconds each. Therefore, the time, we can say for 0.8 kilometers, or sorry, the time for 1.8 kilometers, my apologies, kilograms, 1.8 kilometers, would be equal to 5 times 86.79 seconds plus 4 times 22 seconds. This is giving us 522 seconds. So essentially, that would be your answer for part A. This would be the total time. Now, for part B, however, we only have 3 stations because now they're 3,000 or 3 kilometers apart or 3,000 meters apart. So again, 9,000 meters divided by 3,000 meters. This would be 3 interstation segments. And we can say that we have 2 stops, 22 seconds each. So essentially doing the exact same thing. However, we're trying to solve for the 3,000 meter apart stations. Again, so we can say that 3,000 meters minus 491 meters. This is giving us 2,509 meters at a constant velocity. So let's find that T. So T would then be equal to 2,509 meters divided by the maximum speed, 26.39 meters per second. And then this would be equal to 95.07 seconds. And so one segment would be equal to 37.19 seconds plus 95.07 seconds. This is giving us 132.3 seconds. And at this point, we can solve for the total time. So would be equal to 3 times 132.3 seconds, given that we have 3 interstation segments, and then we have 2 stops at 22 seconds each. So our total time here would be 441 seconds. This would be your total time for part B. That is the end of the solution. Thank you for watching.